So we're going to go over how to find a limit value using some algebraic techniques. In a perfect world, like this example here, you'd be able to plug in your limit value and end up getting a real number. So if we plug in -3 in our x variable, we end up getting a value of -25 over 15, and that can be reduced down further to -5 over 3. Now, that's pretty straightforward, and too bad it just never happens like that in real life, and most likely won't happen on your tests. So we'll go over some different methods on how to solve some of these when you don't get a real value. So for our first example, perhaps the most basic technique is just trying to factor your equation down so you can eliminate some variables. So for this one, we'll have a polynomial on the numerator, and that'll be over a radical 3 x minus 2 radical 3. Now if you were to plug in your limit value here, you would end up just getting a 0 over 0, so obviously that doesn't work. So knowing that I have a polynomial in the numerator, the first thing I want to do is I just want to go ahead and factor that. So I draw my parentheses, and then I'll get both my x values here, and I just kind of use mental math to figure out the rest. So in this case it would just be -2 and a +3. Now for our denominator, you see that we have two like terms, so these radical 3's. We can end up factoring that out and then isolating this x minus 2. So we'll factor this radical 3 out, and then we have our x minus 2 here. And then now, as you can see, we can go ahead and just cancel these out. So both these cancel, and then we can come down here. And we can see that if we were to plug in our limit value here, that we'd end up getting a real number. So we have x plus 3 over radical 3, and then we can plug in our 2. So we'll get 2 plus 3 over radical 3, and that gives us 5 over radical 3. And then we can reduce this down further by multiplying the numerator and denominator by radical 3. And that gives us a final answer of 5 radical 3 over 3. So as you can see, if you have a polynomial in the numerator, first technique to really look at is just see if you can factor it down, and then just try and eliminate from there. Sometimes you'll get an equation that requires some expansion. So we have x 0. So if we were to plug our 0 in here, once again, we'll just get 0 over 0. If you look at the current equation in its form, you can see there's nothing we can really do, except we can try and expand this out and just kind of see where that leads us. So we'll go ahead and do that. So we have x plus 4, x plus 4, and we end up getting x squared plus 8x plus 16. And then we can plug that back into our numerator. So we have x squared plus 8x. And don't forget this extra -16 value here. So I have -16 all over x. We can already cancel these out, and then we can reduce this numerator even further. So you have the x squared plus 8x. We can factor out an x, so we'll factor that x out, and then we'll have x plus 8 all over x. Now that this x is isolated, we can cancel these out, and we can go ahead and solve for this. So it's x plus 8, and that's equal to 0 plus 8, that's equal to 8. So we'll do one more factor style problem. So we'll have a 3x squared plus 7x plus 4 all over radical 3 times x plus 1. So just taking a look at this once again, we have this polynomial in the numerator. We know we're most likely going to factor it. Sometimes the denominator will help you out here. You just assume that you most likely will have to eliminate that. So when we're factoring this, we just do 3x to x. I'm just going to assume that this second one's x plus 1. And to make that work, this would have to be a positive 4. And then that ends up checking out. So and then we'll just go ahead and put that over our denominator. So we have a radical 3 times x plus 1. These will go ahead and cancel out. We'll have 3x plus 4 over radical 3. So we can go ahead and plug in our -1 value here. And then, so that'll give us plus 4 over radical 3. And that's going to equal to 1 over radical 3. And now we can reduce that down further. And here's our final answer, radical 3 over 3. So, like I pointed out before, sometimes you can look at the denominator and see that, you know what, most likely I'm going to try and cancel that out, especially if you have a polynomial in the numerator. So if you're having trouble factoring, just know that'll be a good starting place. Some limits have a radical in the numerator, and those can be a little challenging. For example, this one's going to be a 5x minus 11 minus 2 over x minus 3. So anytime you have a radical in the numerator, you can always assume that you're going to have to take the conjugate value of that numerator. So for example, if you have a value that's a plus b, you're going to have to multiply both the numerator and the denominator by a and b, but you have to swap the signs. So it'll be a, b, a, negative b. So in this case, our radical value here is going to be a, and -2 is going to be b. So we'll go ahead and multiply our numerator and denominator by 5x minus 11 plus 2. Then we have 5x minus 11 plus 2. So when multiplying this all out, we're multiplying these like terms, we'll eliminate this radical. So, and since these are inverse signs, we know that when it's multiplied, when we multiply this -2 by this value, that they're going to just cancel each other out. So what we end up getting is a x minus 11 minus 4. And then we'll put that over x minus 3 times our other conjugate value here. So the numerator can be reduced down further. And don't worry about multiplying this out, because you have this clean x minus 3 value, and you can assume that that will most likely be eliminated. So we'll go ahead and reduce the numerator, or clean it up a little bit. So we have a 5x minus 15, and then we can factor a 5 out, and then end up getting x minus 3. And I'll put that over our denominator, So this will cancel. And that leaves us with 5 over our initial conjugate. So 5x minus 11 plus 2. And then we can go ahead and plug in our x value here. And that goes to radical 4 plus 2. And that's equal to 5 over 4. So just anytime you have a radical in the numerator, just know that you're going to have to find the conjugate term and then multiply both the numerator and denominator by that value. And typically you'll be able to eliminate the necessary variables and then solve from there. Sometimes you will get a fraction in the numerator. So we'll go over a couple of those examples. So for this example, we'll have 1 over 4 plus 1 over x over 4 plus x. So anytime you have like multiple fractions in the numerator like this, you just want to multiply both the numerator and denominator by these fractions like terms. So in this case, we're going to multiply the numerator and denominator by 4x. So we have 4x here, and 4x here. And what that turns into, if we just multiply straight across the top here, we'll have a 4x over 4 plus 4x over x, all divided by 4 plus x, 4x. Once again, we're not going to distribute this right now. So these cancel, these 4's cancel, and this x cancels. So that gives us x plus 4 value over 4 plus x times 4x. So these cancel, and you end up getting 1 over 4x, which once we plug in this value here, we'll get a negative 1 over 16. We'll do one more fraction problem. It's a little bit more challenging. So for this one, we'll have a limit 0, and then we'll have 1 over x plus h squared minus 1 over x squared. So as you see in this one, we have 2 different variables. So the key here would to be just to break it down enough to where we can solve for one variable and still have a function afterwards. So using the same technique here, we're going to multiply both the top and bottom by our common denominator, which in this case would be x squared times x plus h squared. And we'll also do it down here. So x plus h squared, x squared. And then we'll end up getting, once again, just multiplying across the top here. So for this numerator, it'll be a x squared, x plus h squared. And once again, it'll be the same since they're both our numerators are 1. And x squared here. All over x squared, x plus h squared times h. So these go ahead and cancel, and these go ahead and cancel. So what that gives us, it's a value of x squared minus x plus h squared. And once again, our denominator stays unchanged. So we take a look here. It's not a whole lot we can do. So like we did earlier, we're just gonna have to expand this out. So what that ends up turning into is x squared minus, and here's our expansion of this term right here. So x squared plus 2hx plus h squared. That's also over our denominator. So already looking at this, you can already know that these x squares will cancel. And then what you end up with is negative 2hx minus h squared, because you still have to distribute this negative sign going across. So looking at this numerator now, we see we have two h values here. We can go ahead and factor out one of those h values, and that'll help us eliminate this here, because then we'll have that h value isolated. So we'll have h minus, or times negative 2x times negative h so these h's cancel out. So we have a negative 2x minus h over x plus h squared, x squared. And then from here we can just go ahead and plug in. So for h, so we have negative 2x minus 0 over x squared, x plus 0 squared, and we end up with negative 2x. And then don't forget to use the square this, since we have this exponent here, and then that'll be x squared times x squared. And we end up with a negative 2x over x to the fourth, and then this can even be reduced further down to negative 2 over x to the third. And that's our final answer. So you can see how sometimes it can get a little finicky, but at the end of the day, just stick to your basic algebra rules. Try the best as you can to reduce the polynomials down as much as you can, and then just try and find similarities with your numerator and denominator. Also, if there's a radical in the numerator, just use the conjugate value, and then just keep working until you're able to eliminate some things, and eventually you'll end up with a value.